In this video, we're going to discuss the logical connective AND. So recall that a logical statement is a declarative sentence that is unambiguously either true or false. So here are some examples of logical statements. 5 is an integer, that's a true statement. -5 is not a rational number is a false statement. 2 is less than or equal to 5, that's a true statement. 2 cubed is equal to 5, that's a false statement. Pi to the e is less than e to the pi, that's a true statement. 11 is even, happens to be a false statement. And square root of 2 is irrational, so the statement that square root of 2 is an element of the rational numbers is a false statement. What's important here is each of these statements is unambiguously either true or false, so we call them logical statements. In logic, there are four main connectives. They're not, also called negation, and, also called conjunction, or, also called disjunction, implication. In this lecture, we're going to discuss AND. So let's let P and Q be logical statements. Then the phrase P and Q is the logical statement that is true when both P and Q are true, but it's false otherwise. So we denote the statement P and Q with a wedge, P wedge Q. We read that as P and Q. So here's the truth table for P and Q, and just reflects the definition above. So if P and Q are both true, then P and Q is true. But in all other cases, P and Q is false. P and Q is false if Q is false. P and Q is false if P is false. And P and Q is false if both P and Q are false. So P and Q is only true when both P and Q are true. So for example, the statement that 5 is an integer and 2 is less than or equal to 5, that's a true statement because both 5 as an integer is true and 2 less than or equal to 5 is true. On the other hand, consider this statement. The statement -5 is not a rational number and 2 cubed equals 8. That's false, simply because -5 is not a rational number is false. So if we're looking at a conjunction of two statements, once we find one of them to be false, then we don't have to consider whether or not the other one's true or false. We know that the conjunction as a whole is false. Notice that if P is a logical statement, then the statement P and not P is always false. That's because if P is true, then not P is false. And so P and not P is going to be false in that case. And if P is false, not P is true, but P and not P is still false. A statement that is always false because of its logical form is called a contradiction. And in the end, all contradictions come down to this logical form, P and not P. So that's it for this video. Thanks for listening.